All right, so we're going to be looking at questions 3 and 4. I did assign, this is from week 27, sheet 2, I believe. Keep in mind the standard form EULA for cosine or sine curve is this again. Y equals A cosine BX. Now in between the B, there's also the phase shift, which means get that for you guys right now. I want to get the exact formula. I want to see exactly how they write it, so not to confuse you guys. Okay, here. This is better. Let's use this one better. All right. F of t, right? Equaling A sine B t minus C plus D. Right? So I'll rewrite it again right here. A is equal to, sorry guys. A sine BT minus C plus D. Right? Keeping in mind that C is the phase shift, essentially. B is a period. T is a variable that switches with it. And D is the movement about the curve, up or down. Right? So with that general formula in mind, right? Let me erase this top one right here. Some space. We want to find a formula for this one, right? This is the third one. Yeah, okay. So what's the amplitude? Anybody? Can anybody tell me what the amplitude is going to be? Remember, the amplitude goes from the x-axis to the peak, or the x-axis to the valley. Anybody? The amplitude of this is going to be what? Anybody? Anybody? Andrew? Have any thoughts? So the amplitude is going to be 10. See, because from here to here, that's 10. Now the period is going to be from peak to peak, or valley to valley. This looks like it's shaping up to be what? Oh, well, it's basically told us it's shaping up to be a sine curve. Again, sine curves always start from like 0, but it's a sine curve that's shifted by about 0.25. Because if you moved it over about about, let me erase this part right here. If you move this over about, 0.25, you would see that this curve, in other words, if I had a 0.25 or pi over, what is that? It's 180. 180 divided by what is going to give me? It's pi over 4. So sorry, pi over 4, right? So it's a phase shift of pi over 4. So a minus phase shift is going to move me right, and a plus phase shift is going to move me left. So this is going to be a plus pi over 4. And my period is going to be normal. It's just going to be, let me see, if I shift it over one time right here from peak to peak, I'm looking at something a little less than normal. I'm looking at 1.25 pi. So my period is 2 pi. But in this case, I need my b value. My b value isn't quite my period. My b value is just going to be the number of instances that I have this. So in this case, it's going to be, how many instances do I have this? So my b, so this is my b. So if I shifted this over just a little bit, I want to see how many cycles I can get out of this thing right here. Shift it over just a little bit, about pi 4. I get one cycle that will probably end at pi. So my b is going to be 2. And plus 0. In this case, I have an amplitude of 10. All right, that's my answer. Yes. Any questions on that one? I want to see how I got the phase shift. Keep in mind that my normal course of action for a sine curve would be for the curve to begin at 0. In this case, it does not begin at 0. It's actually, at least on the positive side, it's actually beginning around 0.25 or pi over 4. So it's shifted by that much. If I shifted that much more to the left, I would get a normal curve because I would move everything over by about pi over 4 or 0.25. So one cycle would be pi. I put plus 0 for d over here, but you don't have to put anything. It's fine. You can leave it like that. Any questions on that one? No, what's that? What's this one? Okay. So my period right here is going to be pi. My phase shift is going to be pi over 4. My equation is right here. That's my equation. Give me a second to jot that down, guys. Next question. All right, next question. Anybody want to guess what the amplitude for question 4 is? It's a simple one. And this time we're dealing with a cosine function. Mainly because it tells us. Anybody? Anybody have any idea what the amplitude for this one is? Well, okay, so the amplitude is going to be 2. Everyone sees that, right? Now the period we said before was going to be 2 pi over b. The b in this case right here, again, if we look at it at a standard form, f of t equal to a sine b t plus c plus, oh, sorry. In this case, our amplitude is 2. 2 sine, the b value is a period, right? It's not the period. This period is in the form of 2 pi over b. In this case, if you notice that the phase shift is again pi over 4, because look at where this thing hits the x-axis. Over here and over here. If that's a third, then what's slightly between a third and 0 would be about, we can safely assume that it's about pi over 4. So that's the phase shift, right? So again, this phase shifted to the right, so it's minus pi over 4. Right, and again, we had pi over 4 as a phase shift. So now, if we move that over by that amount, right? We would move it over by about a quarter amount, right? So at a point at 50 itself, we would have one full. No, at 50 itself, we would have what? Half a cosine curve, right? And at pi, we would have one full cosine curve. Because right here, this is 50. This is what I mean by 50, guys. Right here, that's going to be 0.50. Right there, if we shifted this everything over, we would have another graph like this. Oh, man, another graph that looks like this. This would be, maybe shifted we have this. Yeah, so let's start over here. This is a cosine curve, mind you. Okay, sorry. I'm not drawing that right. Like that. That's how it would look like. Oh, it's not letting me draw it, so. That's half. That would be a 0.50 essentially. It'll go up again like that. Whatever. But needless to say that one full period or one full cosine curve would be pi itself. Would be 1 itself. Which in this case we could take as being 1 being a full 360, so we think that's 2 pi. So that's one full cycle would be 2 pi. Right? So that means that B is going to be 1. And B is just going to be 1. So it's going to be, so the answer is going to be T. And this one get phase shift is plus 0, right? That's where we're at, guys. Any questions on this, guys? Anybody? Let me know if you have any questions, guys. Because if not, well, we'll continue doing this page again tomorrow. But I do want you guys to also, I think I did assign you some assignments on Stoichiometric that deal with radians and degrees conversion. So I do want you guys to complete that. In addition to that, complete this sheet I gave you. I think it's due tomorrow. And then ask me any questions you may have tomorrow. Oh, okay. Andrew, you want me to explain the phase shift? Okay, the phase shift basically moves this curve one way or the other. So in the first, I guess the easiest way to see it is in the first example, because they actually have it in radian terms. Radian terms meaning pi. If you look at that graph, right, and that's a normal sine curve. That sine curve was shifted to the right by 0.25. So if I was to shift that back to the left, right, to where this part right here, 0.25 becomes this part over here, right, I would get a different curve. I'm trying to draw that curve. It's not really not letting me do that, but I don't know if you guys could trace my hand. Go to the last part. You see it a little bit better that way, guys. That's what a phase shift essentially does. Do you see the overlapping cosine curves? All right, it won't let me do that again. Right, it's sine curve. We good? Oh, there it goes. It's stuck. Let me know if you have any questions, guys. Besides that. All right. Okay. Good. All right, if there's no more questions, guys, then or if there are more questions, you can always leave it in the comments over here, or you can comment once you're doing a sheet through Google Classroom. I'll get the comments instantly, and I'll respond back instantly. All right? Let me know. All right, so then I'm going to end this live session, and I'll see you guys tomorrow. Bye.